Hello, Orion Science. So you guys are going to be functioning as interns, and hopefully you know what an intern is. We're doing a new unit this semester, starting off this semester anyhow. It's called Plate Motion Engineering. So you'll still want to keep in mind that your knowledge of plate motion is important, and we'll focus on tsunamis and designing a early warning uh, system for the people of Sri Lanka. And this will be unlike any other unit that we've done because it's an engineering unit. You'll be using some new terminology like the Futura workspace, which again you'll get to from Amplify. And the Futura workspace is where you will find your daily messages that outlines what your job is for the day. And there's also an engineering notebook that is kind of like a paper copy of a lot of the same stuff that you see in the Futura workspace. However, the notebook has some places that you'll fill out information. Sometimes it's doubling up, but that just ensures that everybody gets what's going on. And those engineering notebooks will stay in the classroom. Please do not call them a packet because I will not know what you are talking about. It is called an engineering notebook. There is also something called a dossier. It's a French word, so it's spelled kind of funny, Dossier, dossier. And that is just a collection of all the readings that you will do. Like, for example, when you're at home, you'll read chapter 1 called Request for Proposals. That'll be found on Google Classroom, just like normal. Check Google Classroom, and there's a Google Doc that goes with that where you'll fill out some information. Just like normal, you'll check Google Classroom, you'll check the Student View, teacher websites. There are a few things in this unit that are made up, they are fictional, and that's just to kind of make it a little bit fun and give it a storyline, but it is based on real things. So Futura is a fictional company, but there are real companies, of course. The National Ocean Administration, or whatever it is, that's made up, but there is a real thing called the National Oceanic and Atmospheric Association where we get a lot of our weather data. And I am your internship coordinator, and Hannah Wong is the director. So, like I said, this unit is a lot different than anything that we've done before, and I'm looking forward to experiencing this with you. One of the things that you need to be aware of is in the Futura workspace, the triangle icon with the ocean wave in the upper right-hand corner is how you're going to get to something called the Tsunami Alert Design Tool. Tsunami Alert is the sim that you will use to design a tsunami warning system for the people of Sri Lanka. And that's going to be where you place earthquake sensors, shallow sensors, and deep sensors. You will come up with design after design after design. You will do it over and over and over and over. So don't get worked up on trying to get something perfect the first time. This is something that we will spend weeks on, and you will get better and better. So just enjoy the process. A lot of times science is all about the process. That's step by step, day by day, live in the moment. And that's why you can spend a lifetime doing science, because you're not going to get the right answer the first time. The earthquake sensors are a lot cheaper if you put them on land than if you put them in water, and you are trying to minimize cost. The shallow water sensors go in the light blue water, shallow water, and they detect changes in the ocean water movement. And the deep ocean sensors go in the dark blue water in the deep ocean, and again they detect changes in the water movement. You're also trying to minimize false alarms. Basically, you're trying to get false alarms to zero, because if you think about it, if you lived on Sri Lanka and there was a warning siren that went off to take shelter immediately because a tsunami is coming, you're packing up your family and all your precious belongings, you're grabbing your phone, you're hopping in your vehicle, or maybe you're walking or taking a bike and you're heading to high ground, like up on the mountain. And then if you find out that there was never a tsunami, then you're going to be angry, right? And you're going to not believe the next warning. So false alarms really need to be at 0. The other criterion that you're trying to accomplish is to, besides minimizing cost and minimizing false alarms, you're trying to maximize warning time. Because say there's an earthquake, 100 miles off the coast of Sri Lanka, if you can give people 30 minutes or an hour or more to get away from the shore where the wave is going to be the most devastating, that's the best scenario. Even though you're trying to minimize cost, though, you're still going to spend millions of dollars, so don't be freaked out by that.